So if you look at each one of these, we have 5. Whoops. Supposed to be right. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we have this. And we have this. And we have this. And we have this. Now, the big key on a lot of these things, if you go through and do it, you find that all of them equal this if you plug them all in correctly to a calculator. So they all equal the exact same thing. Okay, so the hard thing is, which one doesn't belong? And you're like, well, they all have the same answer. Okay. So things that you could kind of think about here is this is all broken down into its smallest parts being multiplied together. So that one might not belong because the others aren't that. This one might not belong because it's down to its smallest parts but has an exponent. But then this one also has an exponent as well. But this one has an exponent that's the only one that has a fraction. This one has numbers that aren't broken all the way down, so that might not be belong. And this one has one number that's, can be broken down further, but then that. So it's just a matter of, can you decipher which one doesn't belong? Even though they all equal the same number, that's kind of an idea about this, which kind of is goofy. So sometimes we might or might not know what would and would not belong, especially if they all come up with the same answer. Okay, so on that answer, none of the answers are wrong, as long as you kind of maybe saw something about it. Like, and I bet you every one of you tried to do the math of all those, I would think, and then all of a sudden you keep getting the same answers. All right, so let's go down to the bottom of this page. Okay, let's go down to the bottom of that page. That's that looks like page 19 in the yellow book, correct? Okay, so I'm on page 19. Y'all with me still? And I know you can't really see the page 19 unless you have the special one that didn't get in the way. So I go from this to this to this to and then that's okay. So talk to me. You're good. You throw it away. So things that you might be able to see up here. So you have dots that are grouped. Agree? So does it look like it has a pattern to it? I think I'm visually, right? Just by a visual inspection, it looks like we have a pattern. Okay? You got your book? Page 19. So what do you notice about the pattern? What do you wonder? I don't know. I mean, I have 3 distinct corners that something seems to be taking place. Does somebody want to tell me what it seems to be taking place with each of the circles? So, what you got? Huh? 3 circles, I'm with you. So what can you tell me about here to here to here to here to here? What do you see within each individual grouping of a circle, just on the top circle? What does it appear that's taken place? Yeah. It doubles every time. Okay. Going from 1 to 2, it doubles. Going from 2 to 4, double 2, and you get 4. From 4 to 8, it doubles. From 8 to 16, you double 8. Okay? So those are some different things. So I bet you there's a pattern. And you remember, what letter do we kind of start with when we're looking at these? What letter seems to be something we start with? What letter was I starting with? Was I starting with N? So at the beginning, 1 minute, 2 minutes, 3 minutes, 4 minutes. So what we want to do is we want to see if we can take this purple number and maybe see if we can plug it in. And if we plug 0 into N is 0, so that would mean no dots. Well, I have 3 dots. So that's not quite right. So how can we maybe start building upon that a little bit more? Oh, okay. So I want to see if we can start making, I want to start seeing if we can start seeing this. So this is on the page 20 on the board. Okay, those are our same patterns, right? That's the same patterns? Agree? So, excuse me. So a pattern that we see, we might be able to say something like this. It doubles each minute. Is that okay? Does that make sense? Does that verbiage make sense? MIN period is I abbreviated minutes. So if they're saying that, let's figure out a couple other things. There was 3 dots here. There was 6 dots here. 12 dots there. 24 there. And 48 there. So when I plug 0 in, I get a 3 out. I plug 1 in, I get a 6 out. If I plug 2 in, I get a 12 out. If I plug a 3 in, I get a 24 out. If I plug a 4 in, I get a 48 out. So the 5th pattern is going to be kind of, let's see, 32. 32. So 32. Or wait. No, wait. If I double, that's 96. 96. 93. Twenty-four, 25, 26, 27, 28, 29, 30, 31, 32. That pattern's not working. It's the right number of dots. Let's see. Another way we can make that work. 32. So if there was in here 16 dots, that means that the green circle on this next one, this green dot here, should have 32 dots if we're doubling, which means each one of them will double. So what times what gives me 32? 1 times 32, 2 times 16. 3 doesn't work. 4 times 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So This would also happen. Let's see. Can I do this? I'm curious if I can do this. Let's see if this is going to work. We're trying something. Paste. Okay, let's move that down here. Let's do another paste. Paste. I'm trying to squeeze it in. All right. So do you feel comfortable with that? Do you comprehend what I'm trying to do? Just trying to show a pattern. I mean, obviously, the more and more dots we have, the less and less space we're going to get. So iteration number 5, or at 5 minutes, we're going to have 3 groups of 32 dots, which means that would give me 96 dots total, 32 dots per green circle. Okay, again, we're starting with N. Okay, so maybe let's try and make a table out of this. Let's see what we can do with a table. Okay, so if I made a table, I could say 0, 3. So we could call this N. We could call this F at N. Right? And then at 1 minute, I have 6 dots. At 2 minutes, I have 12. 3 minutes, I have 24. At 4 minutes, I have 48. And at 5 minutes, I have 96. You feel comfortable with that table? Yeah. I was teaching. Meet me in the hall, if you don't mind. And grab your stuff, you're fine. But just talk to me real quick out here. All right, hey, let's bring it back together. We have a table, yes? Yeah. We all agree. Yeah. Does everyone feel comfortable how I just made that table? Yeah. Is anyone like, this table thing, what's she doing? No. All right, so I'm going to move off this slide, and I'm going to duplicate that table. So we called it N, we call it F at N. We got 0, 1, 2, 3, 4, 5. We got 3, 6, 12, 24, 48, and 96. Okay, so, now we have 2 words. There's something called a recursive equation and explicit equation. And they're basically the same thing. Put that up there on the desk, far corner. Thanks, sir. That's beautiful. All right. So, again, we're going to start with N, and let's think about what N's going to do. Okay. If I'm starting my equation with just N, if I plug 0 in for N, do I get 3 out as it sits? If I plug 0 in for that N, do I get 3? I get 0. Good. Okay? All right. So, does everyone agree? If I plug 0 in right here, this is 0. Yes? No doubt in your mind. So, it has to be a little bit more than N. Agree? Okay, so let's see. Can we start with, what about if I do this? Let's walk back here. If I plug 0 in for N, I get 0 plus 3, which is 3. Hey, that worked there. Agree? Okay. So I'm going to put a check mark right here. That worked right there. Yeah? But it's not going to work on the second one. If I take 1 and plug it in, I get 1 plus 3, and I get 4, cuatro. That's Spanish. See? So plug 1 in. 1 plus 3 is 4. So does it work here?
No.
It's not going to work there. Okay, hang on. I got to think about this for a minute because I'm not quite sure. So I don't think I'm going to change this plus 3 right now. Do you? Because if I change this plus 3, that's going to change the first one, and the first one that wouldn't work. Okay, all right. Trying to think about this. How's this going to work a little bit better? Let's see. I've added. What are the 3 other things I could do? I can add. What's another math operation? Multiply. I can. Subtract. I can. Divide. And then I can get to the weird stuff. I can start raising things to a power. Like exponents. Hey. All right. So, shoot. Shoot is right. Okay, hang on. Let me go back to some. I'm going to go back here real quick. How many groups did I just have? No, how many circles in each group? I'm sorry, I phrased that the wrong way. 3. Everyone agree? Is anyone like, where are you getting this 3 from? So I have, this one has 1, 2, 3. This one has 1, 2, 3, 1, 2, 3. As far as the green kind of circles, rounded items. Okay. All right. So let's see. I wonder if that 3 is going to do anything for us. Let's see if that 3 is going to do anything for us. So, do you think that 3 on the circles that I just talked about is going to be the same as this 3, or it might be? Or what do you think? You got it. Yeah. All right. I don't know if that 3 is because there's 3 groups or not. What I think, hang on, I'm going to try something. It might or might not be right. If I put a 3 out in front of that n, what does it mean it's doing to the n? Multiply? Makes it 3 times something? Okay. All right, hang on. I just changed this, so I got to go back to my first one, make sure it works. If I plug 0 in, I get 3 times 0. 3 times 0 is what? 0. And 0 plus 3 is? 3. Okay, so it works here. Agree?
Yeah.
All right. Hang on. We might be onto something here. All right. I'm going to take this 1. You still with me?
Yeah.
I'm going to plug it in. 3 times 1 is?
3.
3 plus 3 is?
6.
Hey, it worked on the second one. Hey, it worked on the first 2. I bet you if we look at maybe the next one, if it works, I bet you we feel pretty good that it could work. Okay, oh my gosh. Friends, you got to help me. If I take 2 and I plug it in for n, I get 3 times 2, which is 6. 6 plus that 3 is a 9. 9. Oh, it didn't work there. Oh, boy. Man, kick the desk. All right. Okay, now, my stomach tells me, my heart tells me, maybe we might be on the right path. Maybe we might not be on the right path. Maybe not. But I just don't know. Okay, so I want to try something else. So I'm feeling pretty confident with this n plus 3. I'm going to strike this for right now, and I'm going to try that n plus 3. Now, remember I said something earlier, like we had the add, subtract, the multiply, and divide, but there's one other thing that I said. What was the other thing I said? Add, subtract, multiply, and divide. I said those 4 things. What was one other thing I do? Not add, subtract, multiply, and divide. Exponent. All right. Woo! All right, ready? Exponent. Let's see this. Hey, friends. Ready? Squared. N squared. Okay, hang on. Follow me on this. Follow me on my madness. And I know I'm mad, but, hey, it's good. I'm not really mad. I'm just, like, kind of crazy. Local. See? Local? See? See local? No. All right. All right. We're going to try this one more time. We might be on something, but I don't know. We might not. Okay. All right. I think the square might work. It might. But I don't know. If I take 0, 0 squared is 0 times 0. 0 times 0 is? 0. 0 plus 3 is? 3. It worked here. Agree? Yes. Okay. Works here. All right. Let's try it here. I'm going to take 1. Ready? I'm going to take 1. 1 squared is 1 times 1. 1 times 1 is? 1. 1 plus 3 is? Oh, God. So didn't work. Sugar plum fairies, here we come. All right. Okay. I'm going to put that aside for a minute. I want to take it back and rethink one more time. Do this one blue. This one, I bet you it's going to work. Okay, ready? Yes. 2 raised to the n. You with me? Yes. Okay, now, hey, I need to put a little disclaimer there. Ready? Yes. 2 raised to the 0 is equal to 1. 3 raised to the 0 is equal to 1. 4 to the 0 is equal to 1. Okay? So if I take a number and I put it to the 0 power, it's going to be 1. Still with me? Okay, we might be onto something. So, hang on. If I go 2 to the 0 power, 2 to the 0 power is going to give me what? 1. Okay, hang on. 2 to the first power is 2. 2 to the second power is 2 times 2, right? 4. 2 to the third power is 2 times 2 times 2. 8. 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. 2 to the fifth power is 2 times 2 times 2 times 2 times 2, 32. Right? Okay, so 2 to the n is not going to work as it was. Okay, but hang on. Oh, shoot. I think I discovered kind of sort of something. Hang on. Let me go back a slide. You still trust me? All right, hang on. Hey, remember our single yellow circles we counted on 1, 2, on the fourth? We didn't do a yellow on the. I could do a yellow on the fifth one. I could do a yellow right here. Okay. So each of those yellows is one of how many patterns per segment or portion? How many circles do I have in this first one? How many here? How many here? Here? Okay, we got 3. We got 3 in our head. Okay, hang on. Okay, hang on. We're on to something. Okay. All right, ready? I'm going to take 2 and raise it to the n power. And I just want to see if I can make this become the yellow. Okay, hang on. 2 raised to the 0 power. Is there 1 dot in that yellow dot? Yes. Okay. 2 to the first. 2 to the second. 2 to the third. Is that 8? Yes. 2 to the fourth. 16. Is that 16? Yeah. I got it right there, right? 2 to the fifth. 32. How many groups are in each one? How many groups? How many circles per group? 3. Wait a minute, friends. Holy moly, guacamole. Okay. I think that this 3 times 2 raised to the n. Hang on. We might be on something. Okay. All right. Oh, dude and dudettes. Okay. Ready? Here we go. Follow along. 2 to the 0. 1. 1 times 3. Hey, does it work there? Okay. We're 1 for 1. Okay. Woo! Okay, here we go. Ready? 2 to the first is 2. 2 times 3 is
6.
Oh, yeah. We're got another one. All right, ready? 2 to the second. 4. 4 times 3. 4 times 3. 12. Yeah? 12?
Yes.
Holy cow, we got one more to work. All right. Okay. There's no way it's going to work here. Okay, 2 to the third is 2 times 2 times 2. What is 2 times 2 times 2? 8. 8 times 3 is what? No way. Did it work here?
Yes.
Holy cow. Okay, hang on. Wow, we got it to work all the way down to here. I bet you it's not going to work here. Hang on, 2 to the fourth is 2 times 2 times 2 times 2. 16. Is 16 times 3 48?
Yes.
Yeah. Are you kidding me?
No.
All right, there is no way it's going to work on that.
Yes, way it is.
Yes, way. Frank's got my back. All right. 2 to the 5th power.
32.
32. And 32 times 3 is?
96.
Oh, my gosh. Oh, my gosh. So I'm going to say f at n is equal to 2n times 3. This is the equation that worked. Okay. Yes. So they're going to ask for the recursive, and they're also going to ask for the explicit. I'm not sure which one that's going to be yet. Well, I'm going to come up with a different way of doing this. Okay? But that's definitely going to be one of them. And I can't give you the exact verbiage which one it's exactly going to be, but I'm going to get it. Okay? All right. I'm actually going to call this one the explicit equation. Explicit equation. All right. Now, let's just, for my sanity, because friends, I get lost way too often. My wife refuses to take me to the store anymore because I usually go to the front of the store and I have to call over the PA. Well, Susan, sir, please get her husband in the front of the store. I kid you not. So she won't take me to the store anymore. I mean, I kind of did it on purpose, but so I didn't have to go. But the explicit function is like the math operation equation. So explicit math, yeah. I'll talk loud enough you can probably hear me from the other way. Okay. The recursive. We're going to call this right now next equals 2 times the previous. Okay? What that means is, okay, this is twice that. This is twice that. This is twice that. This is twice that. That's twice that. Yay?
Yes.
Okay. All right. So I bet you at some point recursive will change into next, or be changed into something different. But for right now, next is equal to 2 times the previous. Yeah, sure. Oh my gosh.
Yeah.
We just kind of sort of took a look at it. Now, I want to make a graph. Because you notice down there I have a graph. See that graph? Is it okay if I make the graph on here? I'm going to do the best I can. Okay, ready? Ooh, straight line. I'm using the straight tool to make it a straight line. Okay. All right. So down here, I'm going to write 0 here. I'm going to write 1, 2, 3, 4, and 5. Okay, now I'm going off that table right there. That was the same table, right? All right, this is my same table. So I want to count in the y direction, the vertical direction, all the way up to 96. So do you think I should count by ones?
Yeah.
I might be here a while counting all the way up to 96, Frank. I'm good, but I ain't that good. All right. What if we did this? Me too. Okay, so how did I count in the y direction? In the red? By tens? Okay. All right, so let's try and graph this. So 0, 3 is like right here. And I'm going to write that 0, 3 right next to it. Is that okay? Okay, and then my next one, I have 1, 6. So that's going to be a little bit higher. We're going to change some colors here. Okay, and let's change some more colors. Go to my favorite purple. We have 2, 12. So that's up like here. And then 324. I got more colors. Let's see what. Ooh, oh, this is a dynamic blue. All right. 3 what? 324. Let's go orange. 4 what? 448. And then 5 what? 96. All right. Hey, so let me ask you this, my friends. Does this appear to be a straight line? It's not really a straight line, is it? Is it growing?
Yeah.
So it's kind of growing like curved up. Agree? Oh my goodness. Oh my goodness. Oh my goodness. Oh my goodness. Huh. Wow. What time are we out of here?
36.
Oh man, we got plenty of time. Right, plenty of time. Let's take a look. What do you say? What do you say? What do you say we try? What do you say we try? You guys got a lot of homework for the weekend?
No.
Should I be that teacher saying, hey, you're off Monday,
no,
you have more
no,
homework?
no.
You know, because we all love those teachers, right? Ooh. All right, let's clear that
Can I
out.
have some water?
Yeah, hang on, let me just get this.
And can I go after him?
Yeah, you just get water, go together.
Wait, right now?
Hey, wait, well, no, Diddy.
Okay. All right. So my friends, this looks like page 21 in your book. Can you go through the madness of stirrup to see if you can figure out what's going on that page? You want to try it? See if you can try it? You have the rest of the time to start it. Get a really good start on it. And if you don't get it quite done, don't spend any more than 5 minutes this weekend trying to get it done. Deal? We happy? Absolutely.